computer, boom. And I didn't add the sugar. Yes. Okay. Dinner plans. All right. So just sorry about that. I want to see where the screen capture, where the screen sharing is. Where the heck is my screen share? Screen share, it's there. Oop-a-doo. All right. Hopefully you guys can all see this as well. And hopefully my chat window won't just go away. I want to put it on the other screen. There we go. So I want to see what you guys, while we're starting up now, but I want to, these are always just meant to be, and I want to make sure if you guys can hear me okay, that would be great to let me know. But I want to know what you guys need help with. I mean, the whole point of this is I'm going to teach the same lecture the same way every single term. And so maybe it's on me and maybe I'm naive. My view is, hey, let's record the lectures so you can watch them again in advance and then give you extra time if you need extra time or need extra questions to ask any questions you want during the term or beforehand. So great. So the question is, how can I help on stick? I get a lot of, posts on Discord and the like on how do I do this? Or why is my code not working? I'm going to work through a little bit of maybe assignment 1, or I can re-go over pointers or any number of other things, whatever you want. Oh, okay. Interesting. Try catches are normally, so let me think of, this is going to show my age and my naivety in this case. Try and catch blocks are definitely a Java thing that Java loves to do, baked into the system from the very beginning. I'm trying to remember how many times I've used a try catch block in C or C++. Not very often, if ever. I don't think I've ever done a try catch block. I'm not sure if it's even in the language. It could be, and I'm just naive. Just like, unit tests in Java, I don't know how to do a unit test in Java. I know how to do it in C++. So the question was, is it possible to try and catch read access violations? The question is why? And so that's one I would love to point out because it's a repeat problem that we're going to have with a lot of our various things. So let's have a quick look at what we have. And last term, I didn't give this, but here is the data structure for a tree. What the hell does this mean? It means I am going to make a data structure. It is a bundled up chunk of data that has 2 pointers inside of it pointing to other tree nodes, other data structures, just pointing to where they are located, and a number, an ID. That number, that ID number is not going to be, even if it's wrong, it's not going to blow up. So what you're talking about with a read access violation, presumably oftentimes if you're reading from a file and that file's not open or it's null, that's going to blow up in your face. So it depends, Ethan, where you're hitting the read access violation, or you're going past your array. That would also go outside of bounds for an array, and so whether you're reading your memory or not. So it depends on the circumstances. They're great questions asked, though. So can you give me a bit more context? Where are you getting the read access violation? Because ideally, you shouldn't get it at all. You can defensively code with try catch blocks, but that sort of kicks down the problem further down. And let me show you just to help you guys, because this is another question I got from students during the week. So here is gen tree, as in generate a tree. This is given to you for week 1. And we're saying, hey, set up a tree by reading in the file. But it's going to look almost exactly like this. Notice what we have here. Here's the node. Here is the tree node that I'm dealing with. And in fact, I do it right here like this. This is probably more accurate, right? Here's the node I want to deal with. Here are the 2 nodes that I will use afterwards. That's it. So before I did all this, all I did was I set a bunch of IDs for all the nodes. But I might, instead of doing this sort of thing, I could say, create a node. So if I wanted to read from a note from a file, what would I have? Let's see here. Let's do this. Reading from a file. 1, 2, and 3. Oh, let's do 2, 4, and 5. Okay. And let's go to my given. I want to break down this problem. I don't. It keeps on coming up. I did a candidate interview today with somebody that was interviewing for a faculty job here, and she brought it up. And I'm like, yeah, we do that. And I went, oh, but we really should overemphasize it. What I want to be doing for all of these things, every time we do an assignment, no matter what, I want to do a couple of things. First of all, either it's on actual paper or some kind of fancy tablet, what I'm drawing on. This is a drawable tablet, or I got pads paper or paper right next to me. I doodle crap down on paper first. I do not touch code. I do not think about code. Well, I think about code, but I think about it and write it on paper. I do not code until I have the solution. I don't want to think about, or you can doodle it out. So let's doodle something out here. But if I'm trying to read in a file first, and I like pointing this out because other people will think about this as well. So where is read in line number? Read num line. Where is that located? There we go. Read num loads. Okay. Oh, it must be in another file, the other file. Okay. Read tree file. Okay. So what am I doing? First of all, I'm opening the file. Okay. When I open the file, I make sure that this file pointer is not null. That's what this thing here is doing. If it's not null, do this other stuff. So it opened up correctly. I don't want to go anywhere if this doesn't open up correctly. Okay. I'm going to read this in a second, Ethan. Just let me finish my thought here. And once I've done that, I'm pulling off line by line just a bunch of numbers. In fact, that code is given to you to pull off a bunch of numbers. Here we go. I read in a bunch of numbers. Or actually, the next line would be even better. I'm going to read in a bunch of numbers. How many numbers? This number of numbers. That's what I'm going to get in the end. It will take in a line of text that's put into this text buffer. It'll store it into this list of numbers. This is the maximum number of numbers I can store in there, which should be way bigger than what we're going to be dealing with. And I'm just pulling off lines of text and pulling out a bunch of numbers. And that's given to you code. And then the next thing I ask you to do is to find the first node. Because before we did all of this stuff, I got a list of numbers, and I'm going to make a node for each one of those numbers. So first things first, what are my plans? I open the file. I read in this first line here. And in fact, all I want is this thing here. I want to make node 1, node 2, node 3, node 4, node 5, node 6. They could be any number I want. They could be negative 17, 77, whatever the number. It's just an ID. These are just the names, if you will, of all the nodes. I'm just going to make an array of nodes. And then I'm going to figure out where the heck. So when I say 2, 4, and 5, I want to say, where is node 2 in my list of nodes? That's what find node does. So here is me finding the node. I'm looking for node 0 first, or node, let me see here. So this would be, I'm pulling off a list of, get a bunch of numbers, like 2, 4, and 5. The very first number is the node I'm looking for, the current node, the node I want to set up. So for 2, 4, and 5, so let me give you an example. 2, 4, and 5. I should have tabs in between here. I don't think I can put a tab. Can I put a tab in there? Yes, I can. Great. 2, 4, and 5. Okay. This first number here, that's going to be the value 2. And I'm looking for the node with ID 2 in it. That's what find node does. Find the node with ID 2 in it. Put it down. What I want to do is find the node with ID 4 in it, the node with ID 5 in it, and hook crap up. That's it. So I build a bunch of nodes, then I hook them up. Use this to hook up what nodes are connected to. I want to find out the child node. So I will make sure I find another node. Let's say tree node. This is not going to work for all cases. We'll see that in a second. Child 1, let's say. And I could say, find node. This whole thing again. But instead, I'm just going to put a 1 in here. That's fine. All right. So here are the nodes I'm looking for. I'm looking for node number. I'm looking for the node with ID 4 in this list of nodes. This is how many nodes I have in total. When I find it, I put it into child 1. You might notice the issue here. So let's think about this. And I'm going to do one more. And it's not 100% correct. There is something else to think about. Okay. And we will look at that in 1 second after I look at Ethan's comment. All right. So this is child 1 pointers each node. If they aren't inside the print tree, okay, there's a read access violation. So this is the child pointers for each node. If they aren't assigned a print tree, it gives a read access violation. I solved the issue, but I figured it would be a way to where that makes sense. I tried to catch each node, give a violation, and caught it. Oh, you can do a catch. Try a catch. Okay, you're not expected to necessarily do that. Understand the children to null. Yep, that's exactly what you should do. If you don't find a child, set it to null. That means there is no child there. Eventually, I figured out I can just assign each child null and then fill them in later. Yeah. When did we do that? Try catch and gave a redex violation. I try catch block. I was just curious if there's a way to get the compiler to treat it differently for the. No, you wouldn't necessarily get the compiler to treat it differently. And normally, if I would, that's where I put asserts. That's where asserts are my friend. Maybe I'm overusing those. An assert just says, look, here's a sanity check. I expect to see something there. If I don't see it there, blow up. That's the worst thing. That's a big thing. You can do if statements, checking to see like, hey, is the file a valid file? If it is, right, here's my, if the file is a valid file, then the file should be open right here and I can do stuff. I use it as an if statement. I don't want to blow up if the file doesn't exist because there's a good chance it doesn't exist, but I want to make sure it's fine. Can we use this to find the child node? Absolutely, you can use. But do we have the ID of the child, right? This is so again, we have a function called find node. It finds nodes for you. That's what it's there for. It's already written already. So yes, that is the right end. That is a nice approach to it, but you're not going to node 2. You don't know where the heck it is. I could be hooking up node 2 with node 17. I don't know what position it is, so I need to find it in my list of nodes. And so, yeah, find node. Perfect. Yep. Which file do you want? Yeah, and that's perfectly fine for a private thing. So the private message was, can I show each file? I'm assuming here is just a text file. There are tabs in between each one. And I don't have to have these in order. In fact, let's do this. 1, 3. I gotta put a tab in between. 3, 2. Still works. There should be no difference in this at all. And let's move around the 13 and the 12. I am making, didn't say anything about being in a particular order. It happened to be in this order, but it doesn't have to be in that order. And so I don't want to assume where it's located. I just say there's a node. So this should still work when my code works. It should make no difference to your code at the end of the day when I run this thing, because it is finding that node. I will have a list of nodes with IDs 1, 3, 2, 4, 5, each of them a unique, distinct node. I just have a list. I just have an array of these things. So let's go over what this thing looks like again. Here is, I am reading in a list of nodes, and I am putting in the IDs of all, getting all the IDs of all the nodes. That is what this function will do. So I will get, where is it now? 1, 3, 2, 4, 5, 6. That's what's in my array. That's what's in node index list, that array. Okay, once I've done that, now what do? I want to go down through each and every node and make a node. So that's what this thing here is. But notice we've already done something like that before, and I'll go over what A1 given in full details in a second. But I've already done this side of thing before. Here is, where's A1 given? Gentree. Sorry, here we go. Here's Gentree. I'm going to make a bunch of nodes. I'm going to make an ID for each of those nodes. So instead of create node of just some number I would put in whatever the next position in my array was, the value in the next position in my array. It would be create node 1, create node 3, create node 2, create node 4, create node 5, 12, 13, then create node 12. I just call create node, and create node, just to clarify things, creates a node. I know, crazy. It's just a function to wrap up things to make a node that's safe. We can even go to it. So let's have a quick look at this and go to definition, or let's go to definition. Create node. It takes in an ID. I make a tree node. I set the ID. I set the children each to null, meaning that it has no children. Return the node. Done, right? Walk away. This will just, all it's there for is so you don't accidentally forget these two lines. And you might wonder, why would I necessarily need to call this? And my answer is because your professor was dumb enough that he forgot to call those things. So why wouldn't you forget to call them? It's perfectly normal to forget things. The reason we have functions is so it'll save you mental brain power. This creates a node with an ID that's equal to ID. And it sets it up nice and safe. It's a node with no children. Done. That's all it does. It doesn't do anything special. It doesn't, save anyone's life or anything like that. All it's doing is creating a node with no children and gives it an ID. You capitalize. So the question is, would create node be 1 or I plus 1? And it could be whatever you want. It's just an ID. So it could be 40,000. It could be negative 17. It's whatever ID. It's like your student ID. It just identifies the node. I'm saying what my code is saying or assuming is I'm assuming I don't have repetition in these numbers. The ID, node ID 1, there's only one node with node ID 1. There's not 2, there's not 7. Each one of those is unique. I could have had a name for it. I could have done like a text string name for it. I could have done anything for these. I just wanted to have them a unique number, something to store in the node. And then I go hunting for that node later. That's what find node does. Find node walks down this array of nodes. Find node, here we go. This is what I'm looking for. Here's my array of nodes. Pass out the pointer to the node when I find it. That's all it does. It walks down this array of nodes. And as soon as I find a node with the same the ID that I'm looking for, that's what I'm returning. Which is why we have this, because if I want to find the child with ID node with ID 4, call find node. If I want to find the node with ID 2, call find node. Whatever the case is, if I want to find a particular node, I call find node. It finds the node for me. So this is what I was trying to hint at with right here. I'm going to find the node. I could find the next two nodes as well. There's just one little problem with this. I don't want to give away the answer to this problem. But if you run this, let me demonstrate what the problem, there we go. We have a demonstration of the problem already. What happens if I get to this line and I call find node? Bad things are going to happen. Maybe not necessarily, but it's weird things will happen on this line, not the line above, that line. Part of your job, and this is unfortunately what we're trying to teach you, and unfortunately you get taught, everyone gets taught sort of the hard way. What we're trying to teach you is how to methodically analyze, think about code, part by part, bit by bit. Do a little bit, add more, do a little bit, add more. And when something goes wrong, and it always does, you don't throw your hands in the air. You go, what the hell happened? Why did it happen? And I will say, if I'd read the code like I have previously, well, like I have it as written, I'm going to hit a problem right there. That's the line that things are going to blow up. Then the question is, if you're looking at this, so I find node, the first node. So let's go over the first example again. So 2, 4, and 5. I'll find the node with ID 2, the node with ID 4, and the node with ID 5. It does not work on one of the later lines. And the question is why? So actually, maybe you can why wouldn't it work? You can throw it in the chat. That way I'm not giving away answers, but you guys can give away answers to each other. That's fine. Why does it not work in all cases? I'm looking for node 2, node 4, node 5. That's what find node will do. And then I can hook these things up. So afterwards, let's say I would do something like this. Is my caps lock on? Okay. Cur node. And then I need to go to a particular current node. So instead of a dot, I'm using the arrow. Child 1 is equal to, child 1. Great. I'm going to hook my pointers up together, right? So this is what I would expect. At the end of the day, I found the node, I found the two children, I hook them up, just like I did here. So there's nothing new under the sun with this one. Where are we? Let's read. Here we go. Right. There's nothing new under the sun in this one, right? Here's my current node, the node that I'm fixing up. I hook up the two children. That's it. But in this case, I'm saying there's going to be a problem right about here. So what, and I will wait for you guys on this one. I'll have a cup of tea and wait for an answer. Why am I going to have a problem with this code as written? There's definitely a problem there. Why? I showed you even the line that's going to cause the problem. Again, here's the problem. I'll wait. What I also add, let's see how many people we actually have in here. We have a fair number of people, I think, right? Oh, not that many. Okay. And if you don't want to participate, I'm more than happy to close this off. Thank you, Peter. Very nice. Yeah, we had no child too. So what the hell is this going to get returned? Actually, I don't know what it's going to return. The reason I don't know is because I might have old data in that node list, which doesn't get overwritten. There's no child two. So this is just, it might find the previous node or previous child two. So what I might get is it'll say it's hooked up to node 9. It might very well do that for me. Because when I pull in these other nodes, it will say, oh, well, there's a node there. It's node 9. And it's gonna hit problems. Yep, 5 implies to 10, and there's nothing else, right? So I don't want node 5. Please remove your code from that. It's perfectly reasonable initially until you realize how it doesn't scale. So let me change some stuff here. And there you go. All your code breaks. It's perfectly valid. This is a perfectly valid way of doing things. The first node is ID -1. You do not go to position -1 for that node. You don't know where it's located. So you have to find it. You can't just jump to position 5. You can't use the value from the list of numbers. You have to find it. Otherwise, it's going to blow up in your face. And by the way, you don't need to send it privately, by the way. Somebody wrote me privately as well. Perfectly fine code, other than the fact that they were using hard-coded numbers for like 5 instead of finding node 5. I don't know if it's the number is 5. The ID could be -17. I don't know. Let's make it -5. What the hell? Let's be crazy here. All right, -5, -5, -5. All right, still works. That should still work. It's not the location where it's found. It's the ID. You are not student number 1,000, 1,000,000, whatever as your student number. Your student number uniquely identifies you, but that's not the number that's, it's not like Google employee number where you're numbered in sequential order. This is you were given an ID. That's different than the order in an array. So you have to find and if you were looking, you wouldn't be putting the 10. Okay, so you're finding the node. Perfect. Sorry, I was missing that in there. And I wouldn't be putting the number 10. I would find the node again and put it in child 1. And if what I could do, let's have a look at this. What could I do to make sure that I don't have this problem? Well, what I want to do is what I did up here. I don't want to try and catch or anything like that. How many nodes do I have here? Num nodes. So if num nodes is equal to 1, what do I know? So when I read in this line and num nodes is equal to 1, what do I know? And I'll wait for this one too. So if num nodes, after reading in a number of lines, if that number is 1, what do I know? There's no children. Nice. Right? I have one node. There's one node on that line. It's the node itself. This example here, 2, 4, 5, should return 3. There are 3 nodes on the line, right? There are 3 numbers, right? And so I can check. Do I know if I have a child 1? Well, is number of nodes equal to 2? If so, or 2 or greater? If so, child 1 exists. We're fine. How about node 2? Do I know if node 2 exists on the line? Are there 3 or more nodes on the line? Then I know node 2 exists. That number of nodes, that's the reason we have it there. If I know this, I know exactly how many things I can look for. So what I want to do, I want an if statement. I want an if statement to go through this thing. I want to check to see, do I have this number of nodes or do I have this number of nodes? In fact, I might want an if statement to be really paranoid. Check if nums, okay. Nums is greater than or equal to 1. Is the number of numbers greater or equal to, if I get 0, there's no numbers on the line. I don't know what's on the line, but there's no numbers on the line. Maybe they're only letters of the alphabet. Don't do anything. Don't use that line. I don't know what's on that line, but don't use it. Okay, if there's 1 number on it, I can find the current node. If there's 2 numbers on it, I can find child 1. If there's 3 numbers on it, I can find child 2. If there's 4 numbers on it, well, it's badly formatted. I can just go and ignore that. So 3 or more, I know there's child 2. I'm good to go. But all of this, be very, 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 very clear about this. All of this stuff, none of this came from on high. It didn't pop up in my head. It didn't just like, whang, I know everything. This is all I write out an outline, like an outline to a play, like an outline to an essay, like an outline to anything else. I write how I'm going to do this. And then I break a big problem into small little chunks. And when I have that little chunk, I then figure out how to do that chunk. So my thought is I make a bunch of notes because I need to know what the nodes are in advance. Oh, I didn't know that, by the way. First, I had to figure that out myself. So I need to represent a tree somehow in a text file. I need to know what nodes there are. I need to know how they're hooked up. So what I'm asking for in this case is I have all the IDs at the beginning so I can make all my nodes. And then I go line by line afterwards, hooking up the nodes. So I know the current node and the 2 children, child 1, child 2. Current node, child 1, child 2. Current node, child 1, child 2. You could do something like this. It would be crazy, but you could do this. And you might want to also do a check for this as well. If find node returns null, as in it doesn't find anything, well, you can actually still set up that child to be that, right? You set the child to null, which means you don't have a child there. But that's the kinds of things you want to be thinking about. Like, what happens if you give me bad data? What happens if this is poorly formatted? How do I make sure I find things? If I have this node and the 2 children, how do I find a methodical way of finding those nodes again and hooking them up? Because all I need to do is hook up the pointers, right? This node connects to this node and this node. That's what I need. Let's see if I can actually generate a nice little. I'm not sure if this is actually going to do it for me, but here we go. I used a -1, right? Okay, -1. And this will be, unfortunately, only for people that are in here. Can you see that? Right. This is node 1. It has 2 children. Those children are pointing to nothing right now. Null and null. And what I want to say is, okay, they're actually going to point to 2, and they're going to point to the node with a 3 in it. Oh, and by the way, they have nothing. They have no children. Okay. Now that I found this, I then find in my array this thing here. And then I find node 4 and node 5, and I hook those up. And so that's all I'm doing. Node 4 and node 5. Over and over again. Can I unpack A1 given again for anybody, or is there something about those particular functions that are confusing people? Can I explain pointers again? The idea of pointers are something you cannot get away with from. You cannot learn C and C++ without pointers. Really? Because you cannot make a tree, you cannot make a linked list without a pointer, because you need to point to something else that you don't know if it exists or not. By the way, so our ID, by the way, will never be null. I mean, it'll allow you to it'll be null because it's equal to the number 0, but it's not actually null. A pointer is null. It's either an address in space, or it's null as in it's pointing to nothing, just pointing at the ceiling and just like, yeah, it's not pointing to anything. So if you're using the term null, you should exclusively use it for pointers. And so when I say something is null, I'm saying the pointer to this thing is null. It's pointing to nothing. It's a safety measure to make sure that you know that it's not pointing to anything meaningful, because otherwise you don't know. All right. You have to find a child node. Let's say 2. Can I just use this? Find node. Your syntax is there syntax wrong with that? Question mark. You would have to have the alternate branch in there. I put in an alternate branch. You're doing a ternary expression, right? Or maybe you're not doing a ternary. Use this for the child node. Current node is equal to find node. This. That should do it. You're looking for the value. Well, this would be the number 4 in that array of numbers that we have. We have nothing right now in our, we have nothing here with 4 elements, but if you had a 4th element, absolutely, yeah. If you're looking for it in this thing, yeah, sure. But by that point in time, once you have that array of nodes, this A nodes thing that you have here, once you have A nodes, you don't really need what. So I've made on my array of nodes. I don't need that first line anymore. But is it for only one child? You're finding a node with a particular index or number list. So in our case, I was looking at a list of numbers with, let's say, 2, 4, and 5. I would look at position 0, position 1, position 2. Oh, yeah, but it's not the number 4 in that case. What you have there, node index list at position 4, is the element after that. It's index 4, not the ID number that you're looking for. So what you'd want there instead of that 4, for what you have here is, I don't know, maybe I can put it over here and you can see it because nothing's private in this part. What you have here is my node index list. This is the list of numbers I've pulled in, right? It's just a list of numbers. But at position 4, that's outside of my array bounds. I have, well, it's actually not necessarily, but it's the 4th number in my array. In this case, if you're wanting that 4, that element number 4, it's at position 1, not position 4, if that makes sense. So I'm looking at position 1 where that 4 is. Position 0 has the 2 in it. Position 2 has a -5 in it. All right, well, you have 5 instead of -5, but sure, because I changed it to -5, but sure, right? Position 0, 1, 2. And therefore, I'm not going to be looking at position 4 in here. If I want that 4, it's at position 1, 0, 1. Hopefully that makes some semblance of sense. But other than that, yeah, I call find node. I find the node I'm looking for in this array of nodes. So I have 3 numbers in that array at position 0, 1, and 2. And so if I have 3 numbers in total, I can check the position 0, position 1, position 2, and I can just pull off the number in it. So if I went back to what I had earlier, here we go. At index 1, give me the value. That's where child 1 is. That's the value, the number 4 that we were pulling off. Here is the number 2 that we were pulling off. I want to keep it as simple as possible. I don't want to be cutting corners. I don't want to be trying to make it all fit on one line or anything like that. I want to get the current node. I want to get each of the children if there is a child. Heck, I don't even need I should always check to see if there's 2 children or not. But I get the children and then I hook them up. And if I don't know if I have the right number of children, I should use some kind of if statement to handle the logic. Here's hopefully the other thing I want to very, very clearly point out because it keeps on biting us in the ass. Okay, what is wrong with isLeaf? Well, I didn't do it. That's the actual problem that's wrong with it. But maybe I want to know what's going on. So let's see. There we go. I have an assert is connected is in here. Oh, I had this as a problem earlier, so let's do it again. Hopefully that's going to work. I'm hoping I'm not blowing things up on me here. Okay, this should blow up my face. I'm expecting it to blow up in my face. But I'm going to pretend I don't know what's going to happen. Okay. There we go. Blows up in my face. The whole point of an assert is I want to see when things go horribly, horribly wrong. No, I can retry if I want to, but that'll pop me in this particular line. And I go, what the hell's going wrong with this thing? Well, what I want to do is figure out what's going wrong with this thing. Why is this thing blowing up? So I go to the definition of something. F12 will do that. And what I really want to do is when I'm stuck on something, I click on this side here and I figure out why the heck my numbers are wrong. What I don't know what's causing all of these problems. I do in this case. Why? Because I didn't implement this yet. But a breakpoint allows you to look at what the data looks like before you start. So let's see if let me make it wrong. Let's just close this off and let me make it wrong on purpose. Okay. Okay. So it's a tree. It's a leaf node. Is it a leaf node? I want to say if p node is not equal to null. I want to check to see if it's not equal to null, by the way. That's a normal saying. And p node child 1 does not equal null. P no, let's see. Let's say child 2 does not equal to null. Is that going to work for me? I'm trying to figure out a way to make it really broken and horrible. This might still pass, so that's unfortunate. Return true. Oh, let's do the return false version of it. Okay. If p null is equal to null, or p child one is equal to null. I'm intentionally making it wrong. P node child 2 is equal to null. Return false. So if p node, the main node, is null, or if child 1 is null, or if child 2 is null, return it's false. Otherwise, return true. It's completely wrong, by the way. It's wrong in multiple ways. Okay. And I want to see what the heck's going on. So if I don't know what's going on, I'm going to click on the bar over here and I'm going to see what happens. Why? Because I don't know what's going to happen. I want to find out. So I run my code. It stops on the line of code that I'm dealing with, and I can check out what I'm looking at. P node, I can just hover over this thing and say, okay, here's the value for P node. It's not equal to null. The ID is equal to 0. The child is equal to this, and I should have another child, and that's equal to that. So it has 2 children. That's weird, but okay, let's walk over it. So I can keep on I can step over, do the next step. That's what step over is, F10. And I'm going to return true. And what the hell? Okay, so let me take a quick pause and go, what the hell? What was it wrong? What was wrong with this? There's a whole bunch of stuff wrong, by the way. There's an exception thrown. I would expect the root, which has 2 children to it. When I make this, I hand generated this tree. Let's see where it is. Gen tree. I'm looking for gen tree. There it is, right? I hand make this. My root node is at position 0. I hook onto it 2 children. It is certainly not a leaf node. It's at the very top, and there's a bunch of branches underneath it. It looks like this thing, right? There are nodes underneath it. So why is it saying that it is a leaf? And that's what I would do as my breakpoint for. So what was wrong with my code? It is wrong. So I go back to it. Maybe I'll run it again. All right. What is wrong with my code? So first of all, what does this do? If p null is equal to null, p node is equal to null, as in the thing is null, and if child, you can say that's true or false because it's not a leaf node. It's not a node at all. It's empty. It's a big problem actually. Or if child 1 is equal to null, or if child 2 is equal to null, return false. Otherwise, return true. What is a leaf node? I'll wait again. And Peter, you saved everyone last time. I'm wondering if other people can. All right. Other way around. Nice instinct, though. Is the node that has a parent? No, almost every node has a parent other than the root. No child. Exactly. A leaf node, it's the leaf of a tree. There's no more branches. It's the end of the tree. The root of the tree is the bottom of the tree. The leaf is at the very end of the tree. There's nothing else attached to it. So a leaf node, in this example, 3 is a leaf node. It has no children. There are no children, 2, 3 at all here. It's a leaf node. It's a very, very, very common term, by the way, in case you're wondering. It's not me being a finicky jerk about things. So in this case, when should it return true? And I want to, when I'm coding, I plan it before I code. So when is it a leaf node? It has no children, actually. So no, it's actually said it perfectly. So how would I test that? Both children return null, or both children are null. So child 1 is equal to null, and child 2 is equal to null. Hint, hint, wink, wink, nudge, nudge. And exactly, nice. Okay, let's change this up. If they're both null, and so what should I return in that case? I should return true. It is a leaf node. And in that case, the other scenario, I should be returning false. And that's my problem. I did it completely backwards, which I have done more times than I care to count. I don't do it all the time, but every once in a while you do something stupid, like you're copying and pasting code. You're writing thousands and thousands and thousands of lines of code. You're going to screw something up, right? Just inverting things by accident. Debugging it is what saves you. It's what everybody goes through. It is not a sign of weakness. It is what the job is. And so your job is to figure out why your code doesn't work and go step by step. And if you get stuck, you can ask, but there are people that are like, it blew up. I don't know what's going on. Put a breakpoint. Just click on the side, boom, pop down a breakpoint. It'll stop at that line of code. Heck, we can do one step further and we can do something like this. Print F and node ID is leaf call. This is the classic to the point that we make fun of the fact it's the classic and it's brute force of ignorance and we like it. Is what happens if we have, if things go wrong, put out a print statement, see what it says. By the way, this print statement will be a world of problems if something happens. If this thing is null, you're going to have it's going to blow up in your face before you even get to the print statement. So do I want to remove this? If it's equal to null, I can't even check. So I want to say it's not. So if it's not equal to null, and this and that, return true, otherwise return false, as in it is not a leaf node if it doesn't exist. That would be perfectly fine. You're breaking down the logic, and most of it, like a math problem, you don't do it in your head, you do it on paper, right? So what am I looking at here? To the point that my wife, when she writes her code, she does extensive write-ups, like draws everything out, then she writes it up, and then she redoes it again clean. Like, it's a lot more work, but I mean, she doesn't have bugs in her code. So in this case, if it's not equal to null, and there's a child, and there's another child, if there's no, if there's no child 1 and there's no child 2, then I will return true. It is leaf node. If there's any child whatsoever, or if the node itself is null, I return false. It's not a leaf node. It's not a node at all. It doesn't exist. So that's fine. It's you think through your logic step by step. But the problem with this thing here is if the node does not exist, yeah, we're going to have some problems. So I might, the smarter thing would be to hedge my bets around this thing here and do something like, I don't know, if, geez, I can't type it all today. New keyboard. If, wow. How, third time's the charm. Okay. P does not equal null. If P node is not equal to null, as in there is a node there, then I can actually get the ID. Because if this thing is equal to null, that's going to blow up in my face. This is not what I want to see at all, right? If I try and call this with P node is equal to null, this thing blows up. I could have also just put an assert. Assert P node is not equal to 0. Why? Because if it's null, that's bad. I shouldn't be calling this function if on a null. It might be a pointer to a node, but if I pass in a null pointer, what do I do with that? I don't know what I do with that. Blow up if I want to do that. Okay. Notice if I don't get this printf statement, and if I don't get this printf statement, and I do know I call is node leaf, what can I conclude? If I don't get a printf statement here, I know, yeah, it's null. Thank you, Peter. Then I know it's null, and I can deduce how my code is working. It's not guesswork. This is not me just rolling the dice and see what happens. And I sure as hell don't write all my code and then see what happens. I write is leaf node, check it. I write is connected, check it, make sure it works, move on to the next part. I don't go barreling through code. There is not a sign of, it's a sign of weakness to not think through your code, actually, right? There's no sign of weakness in doing things in a methodical way. It's actually the job. So do a little bit, test, do a little bit, test, and then you don't get 400 compiler errors when something goes wrong. I know I'm saying this, but I have a sneaky suspicion that some people are hitting problems with this as a result of this, because it's what I would do. I want to write all this code all in one go and then see if it works. And it bites me again and again and again. Do it on paper, do a little bit at a time, deduce what your code is doing, whichever way you need to deduce it, either print statements, asserts, whatever the case is. Yeah, everyone's guilty of that, right? It's what people do. And it's the thing we're trying to get you out of, is trying to print it all at once and not testing, right? That's why I keep on asking questions like, how would I test this code? And by the way, possible exam question for exam 1, how would I test this code? I put it on the last term's exam question, right? Or what would I expect for output for this function, right? You're thinking through what the situation is. So what I want to do here is, what kind of test would I throw at this thing? Tests I would throw at is connected. What if the parent is null? What if the child is null, right? What would we expect in those situations? What if the parent and the child have nothing to do with each other whatsoever? What if the child and the parent and the child are inverted, so that the child is actually the parent and the parent is actually the child? So we just accidentally put the parameters in the wrong order. What would you expect it to do, right? Even if you don't know if you can either ask me if you don't know the answer and you're not sure, or if you have a pretty good guess, state what your assumption is. I'm assuming if the child comes before the parent in the parameters, then it is not connected, because we're checking to see if the parent is connected to the child. Otherwise, true if the parent has child as a child, right? The only possibility is if the parent has child as the child. If you reverse those things, it should return false, right? It returns false. It doesn't blow up or yell at you or anything like that. It just returns false. It's not connected. They're connected in reverse order. You reverse the polarity of this thing, right? Each one of these things, every function you write, think about what goes in, what comes out, what you expect to happen, and then write the test for what you would expect to happen, which is what we're doing over here. Add some tests, put in a printf statement, right? Is connected for the root and the first child. I expect this to be true, right? So is connected, the root and child 1, I'm asserting that is going to always be true. I manually set this up that way. I could also have had on a printf statement saying this node is connected to this node, true, and have a little comment saying I predicted it would be true. You're just trying to think before you code, not just throwing crap at the wall. And it sounds like, why are we doing that? But it just saves you time. You don't, it's, what's the best analogy here? It's if you're cooking or you're doing almost anything that you do, if you rush it before you're supposed to rush it, it doesn't work, right? You can't rush a souffle, right? It'll deflate and you'll have to do it all over again. This thing is, you will spend days debugging code. You'll spend about 4 times longer debugging your code if you do it in a half-ass, unorthodox way initially than if you methodically go one function at a time, figure out what it says, figure out what it does, doodle some stuff out on paper, figure out what the output should be, test it, move on. A little bit at a time. And if you try and do it the night, that's why you can't do it the night beforehand, because you'll invariably will try and rush it, and invariably it will go horribly, horribly south. It'll go really awry, and you'll be like, "Ah, crap!" Right? Okay. Yeah, breaking key. Oh, when I start breaking keys, and I get pen and paper. There are some people that don't mind the dive in first, but most people, the issue with that, and so I don't know if you can everyone can read the chat, but testing the waters by just coding, and everybody wants to do that. The issue is, are you willing to throw out 400 lines of code? I'm not. Every time it happens, I'll write a bunch of code and I'll be like, oh, how about if I change this? Oh, how about if I change? And you do these little incremental changes versus toss the damn thing out, start fresh, right? It's amazing. Sometimes you just want to throw the whole thing away, start again. And you can do that. You would be more than happy to do that with a piece of paper, right? If your approach doesn't work, you crumple it up into a ball, throw it away. The paper way is allowing you to throw away an idea without feeling guilty about it. If you write it up formally, it's like you writing the first, four chapters of a novel, let's say, and then saying, "Oh, that's not the right idea." Crumple up the whole thing, throw it away. No one's going to do that. You do the outline, yeah, you crumple it up and throw it away. That's not a problem. So you won't necessarily write everything on paper all the way through every last little minuscule detail. Sometimes, yeah, I have a real hard time holding myself back, but try to plan it out beforehand. What goes in, what comes out, what would you expect the test to run? You can just put those tests in afterwards. And then, break about your code. If it's something nasty, like I'm reading in a text file and making a tree, that's huge. That's a big, monstrous task. Break it into chunks. I open a text file. I read in each line of the text file. After each line, I'm going to create a bunch of nodes based on the first line. Then I'm going to find each of the nodes and their children, hook them up for each of the lines afterwards by going line by line in my text file. And afterwards, I close my text file and I have a tree. But it's overwhelming if you're not doing that. I know I'd be crying if I was given this task and I didn't break it down into little chunks. That's what we're asking for, which is why this was given, right? Here is, okay, I'm going to make some random scratch buffer. Here's my to-do, open the file. Here's my to-do, read in the first line and make a bunch of nodes. Here's my next to-do. For each of these lines in the text file afterwards, hook up the parent and the children based off the ID. Close off my file, end everything. And while you're doing this, you're doing a little bit at a time, you can test it. You can write a little function, test the crap out of it, throw 15 different calls on it. I don't care. That's fine. If you're testing your code, you know that it's going to, and you know it's working well for a whole bunch of different inputs, test different inputs, right? If I give you this text file, now with -1 and -5 and a bunch of, and there's a -9 here. 9's not even going to be hooked up at the end, by the way, if you didn't notice. This is going to connect 4, 8, and then 4 is going to be the second child is going to be null, and then 9's not going to be hooked up to the tree at all. I would also, speaking of which, I would get this text file and break down what the heck all this stuff does. Where are all these things? What will my code do? I will have how many different nodes? I'll have 1, 2, 3, 4, 5, 6. Well, 13. It should be 13. It was 13 things there. Okay. Are they all connected up? How are they connected in a tree? What does it look like? If I change this, what does the tree look like? Draw it out. Okay. I've been yammering on here. So let me see if I can unpack any additional questions you guys have. I'm really trying to drive home the holy God, test your code. Holy cow, do it on paper, think it through, then code. The coding should not take you long at all. In fact, the amount of code you write here is relatively minuscule. The difference is you can spend days trial and erroring this thing, which I have done. And every single time I've done anything in graphics, every time I'm like, how about -4? How about -3? How about 17? I just tried various numbers and see if it works. And it, you spend days and then you forgot that you've made that change in that other part. And you could just spend hours of spinning your wheels. Do a little bit at a time. All right. Can I shouldn't be admitting to all of my horrible things that everyone goes through, that everyone does those horrible things, but that is what we're trying to teach you. Can I unpack something else for people? Other parts of the assignment, future questions. We're about to hit strings. We're about to hit objects soon. Where we are in the class right now. Oh, Sean, this should not be taking you 14 hours, buddy. Oh, I'm so sorry. Is it like the assignment itself is 30 minutes of typing? Less? If you do it right, of course, right? But if you're trial and erroring anything at all, you're just going to hemorrhage time a little bit. So the first assignment, before you read in the file, it was, so for week 1, just to get, legs under, and there could be also understanding what the code does. But week 1 was, is leaf node. And then afterwards, it's is connected. See what that thing does. And I think that's it, actually. Oh, I think I had to do a couple extra tests in here. Test your tree using a printf and asserts. Okay, so print tree is done for you automatically. You could have tested to see if it looks fine. And then I'd do a bunch of tests afterwards, what you'd expect it to do, what you expect to see. And that's week 1. And then week 2 is reading in the text file. But it was little bits at a time will save you, because it'll actually compile and run as given. The week 1 file using Gentree, the week 2 file uses the tree format for the text file, but they both make a tree, and the trees just work with the same kind of test. You just throw same kinds of tests at the new tree and you're fine. Or make the same tree, make it identical, just make it look like you use the same, make the tree format look the same. What do you mean by define tree node? Oh, do I actually still have that in there? Here is tree node. It was, hey, you need to define tree node. Here you go. Oh, yeah. Define tree node. This was a to-do, but it was already defined for you. And the midway file and the submission file are different submissions, but the midway file is keeping you on track. Oh, I'm so sorry. Ask, please, please. There's little things that I'm going to miss along the way. So A1, week 1, we're defining this. And by the way, it's because it was an A1 given. There wasn't anything really for you to type into the given file. So I figured people were just going to stare at this thing here, leave this thing alone, not even look at it. And yeah, because it was the given stuff. And we intentionally put it in another file because people were reading it and going, oh my God, I'm reading all this stuff. the 14 hours just to see what the heck was called, and instead of asking. I'm fallible. I keep saying that too often, but it's because everyone keeps on not asking me questions, afraid to look stupid. And you're like, I make a profession out of looking stupid. It's fine. Ask. Right? Especially if you've spent like an hour looking at something, ask. It's fine. That's also why I want to do these little pod things, right? That's why we have this Q&A session. Ask. It's what that's what it's here for. You're not expected to know it before you got into class. You learn it by doing, falling on your face like everybody does, and going, oh, that's what. So the given code is each week when I produce anything. Oh, so the pods, we're trying, and so Pat is taking the ball on a lot of this because he's very passionate. He was actually just teaching at Dalhousie. So the plan of attack right now is we want to have some good motivation to do a pod, because it's one person prepares a bunch of stuff. That's the pod leader. The other people in your pod that you want to work with review the person that's the pod leader. Everyone should take turns being pod leader, like about a third of the time if there's three people in the group. And all it is you get to talk to your friends or people that you just met and make friends with them. But it's not about extra work or anything. It's about getting you guys socializing a little bit. Oh yeah, read tree files a pain in the ass. I will but that's week 2. So hopefully you had your feet underneath you after isleaf and is connected. Anyways, for the pods, the idea is if you're in a pod, one person's doing this extra work so they can teach others, because that actually is the best teacher. When you teach others, you will learn it better than you could ever imagine. The people that are the lab minions, I like the term, they have to do a quick little survey at the end of the lab period just to say, hey, this person was pretty good. They came prepared, or didn't come prepared, as part of the review process. Because we want to motivate people to do that, because it's a little tiny bit extra work. As a result of that, we made it so we're not going to punish people for not, we're not going to take off 5% for not being part of a pod or anything like that, despite what we wanted to make the pods optional after upon further introspection. So instead, what we're going to be doing is we might have, I think the plan is right now is people that are not in a pod, you have to write a couple questions that you can pass, that you pass in. You write your own questions for the course. You pass it in, we bundle it up, send it off to everyone and say, hey, this is study material. Here's a whole bunch of questions you can do to practice for the final exam. So essentially, you make questions for other people to answer to help them study for the final exam. So you have to do a little bit more work at the end because you weren't doing the surveys all throughout the term, but you're still helping out everyone else. And quite frankly, making a question is a great way to learn as well. It's almost like it's behind. But I'm having an issue with Hello World part at the top of the program. I think. For which this is for Hello World with the Hello World. Oh, the whole world, Hello World program, or what's? For A1 though, or is this a different program? Sorry, Jacob. A1, okay. Okay. And let's see here. Unless you made a Hello World program, which could, okay, so that would be the problem. Okay. In main, here's my, okay, there's Hello World. Thank you. Has this number of nodes. Starting with this, has this number of nodes added, and we need to get the root ID. Okay. Yeah, it's the printf. Thanks, guys. So, and this is the number of nodes that we have. Now, if Gentree didn't actually work correctly, is your printf, the question is, Jacob, is your printf working when you use Gentree? Is it only breaking down when you go and read tree file? Because that'll do it. Okay, so Gentree should automatically be there. So I don't know. I'd have to look at your code. Maybe you can send it my way via Discord or something. If you're using Gentry, tinfo should be perfectly fine. You shouldn't have to do squat to that thing. At least I don't think you should have to do anything to it. So if this is generating the tree for you with all the data in it, this is just going, okay, find the tree that's in this tree info. It's just a pointer. It's just a tree data structure that has a pointer to the root. That's all it is. And I go to the root. I pull off the first ID in that from the root. Oh, fix the error. There's one error. There is one error. You're right. I shouldn't have done that to you guys. I'm a jerk. So let's see. Where's my Gentry? My thing is frozen. It looks like. Ugh. All right. Here we go. So read num line. Okay, it's further down. Gentry. And I said there's something wrong with tinfo. Oh, that was the error I actually made myself. You could have actually done this fix as well already. It's not a huge number. It looks like a huge number. Let's actually do that fix. Hold on a second. Let me do this. Tinfo. Oh, actually, we might be able to find this. Okay, let's have a look. Yeah, there it is. Nice. What the hell is this? It's huge. You're right. I still have it in there. But a problem like that when I confirm Gentry and uncomment read tree line doesn't need to get anything on the debug console. You don't. If you don't have it on the debug console, put a breakpoint in your actual code when you're doing read tree file. Let's go over this problem here first, and then I can maybe look into it. Because you're right. It looks like a giant number, doesn't it? Let's put a breakpoint in because that's weird, right? Let's breakpoint this thing. Okay. So after Gentry, I'm going to drop a breakpoint in here. Let's, I want to stop this whole code thing. I want to run it again. All right. Okay. And so what I want to know is the issue was, it wasn't that first number, it was that second number. It's num nodes, right? That's what the issue is. Okay, let's look at num nodes. So tree info, and I got a bunch of stuff in there. So let's actually throw this in. I just watch it if I want. I got to always find out where to add to watch. Okay. It's easier this way. Okay. Whoa. What the heck? It's a huge number. Why? It's almost like I'm hinting at something we did in 1400 that I'm hoping you remembered. Let's do something a little weird. And this is where you would actually go, that why is it a huge number? Why is it such a huge number? I didn't set it. So let's do a hexadecimal display. That's not a coincidence. It's CCCCCCC. Now, the question was, why is it such a huge number? And then my question to you guys is, well, I didn't do anything to num nodes. So why is it such a huge number? Does anyone have an answer to that? Because you didn't do anything to it. That's exactly right, Peter. I didn't set the value. It doesn't give me safe values. I didn't set a variable, and it just went, this is my default in that position. It's garbage, but it's the default in that position. It is an uninitialized variable, and it is exactly the mistake I made myself when writing this code initially. And went, I fixed that and went, wait, maybe we should unfix that for a second and point out this issue. Everybody does it. You forget to set a variable. The reason we have create node is because everybody forgets to set the children to null, and you'll get random weird crap happening. This one is, I wanted to slap you sort of in the face and go like, hey, set your variables. You got to set your variables. You always got to set your variables. So if this is in fact the case, what I really want to do is something like tinfo dot num nodes, and I want to see how many nodes I actually have in this thing, or maybe I already know how many nodes I end up having in this thing. So let's have a look at this thing here. I think there's a predefined number here for the number of nodes. It's num nodes. Yeah, there's 12 of them. How do I know? Because I make 12 of them right here. That's my constant. I'm just going to use that constant. I know how big this is. The better thing to do would be to fix it in Gentry, but I can just plop it down here. Okay. And I compile it. It's a great question, by the way. Just that's why we're doing so many of these things. They're meant to be learning where you go, oh crap, where you learn things, not the hard way, but where you learn things like everybody else learns. Everybody will forget to change their null. They'll free up memory, let's say, forget to set it to null, and they'll get random crap that they'll spend hours debugging. Everybody goes through it. Everybody will not initialize a variable. Everybody will have a pointer that doesn't point to anything, or a pointer that is that's circular, or any number of things, or they'll have an infinite loop. Everybody does it. Yeah, put in the header file. It's also fine. I guess it works well if you put in main. The header file is technically better, but I said you didn't have to modify the header file. That's the only reason I did it there. So you can just submit the one CPP file and you're good to go. But yeah, if you want to change the header file, go for it. Perfectly fine. You just need to submit the header file too. And I want to see what this thing looks like. Okay, so I want to look at my thing and just want to make sure it got sorted out. And I'm not going to do hexadecimal display. 13. Great. That's how big it is. Nice. Yeah, both would be fine. And that's the answer, Jacob. Very nice. So these are the questions I love to get because I want to unstick you guys. I need you to hit things that are tripping hazards, right? That you learn by hitting these things, but I don't want you suffering. I need you hitting them just enough to go, oh, I shouldn't do that anymore, and then move on, right? And that's where that part, I don't know where you're going to trip up. And that's where asking for help, coming to office hours, going to the Q&A session like we're in right now, all of those come in handy for that reason. All right. I'm smelling dinner and I'm hearing a bunch of screaming kids downstairs. So I want to see if you guys have additional questions, but I don't have other things I really wanted to go over with you guys. This is meant for you guys to get unstuck. And it's every Wednesday. That's dedicated time for you guys. No problem. That's what we're here for. That's what we want to do. Also on Fridays, I do believe Pat is going to be he's not only doing the labs, but if you want any questions about anything, line 4, when I uncomment it just stops working. Okay, where's line 5? This one right here, right? You also probably want to do this one here. You need to comment out the other line, right? The gen tree one. And now you need to actually fill in this. That makes sense? So you can't have two variables with the same name, and it won't compile if you have two variables with the same name. Yep, I'll confuse how to tell what's connected to what. Okay, so here is I got a bunch of structs here, but they're not really. So each node is what I showed here. I got some data and I got pointers to what it's connected to. That's it. Hopefully that makes sense, right? And the only way to know what's connected to what is you just follow what's child 1. Oh, it's this node. Hey, what's child 2? It's this node. It's just a pointer. It points to another thing, right? Who is you don't need to have, my son doesn't need to have a name tag around. You know he's my child, and I can point to my child, and my child, you can follow what my family tree is by that, right? Why is it set to save value? It's not. Why is it not? Because it's C++ and C. Honest to God, I wish I had a better answer than that. C++ and C, the conventional wisdom, especially given the age of the language, was, oh my God, you can save so much CPU time by not setting values to safe values. People should be smart enough to set them themselves if they need to. Because if you don't need to set it, why set it twice when you can set it once, right? If I'm going to set the ID to some value anyways, why set it to 0? I'm going to set the value anyways. And there are people that will swear up and down and will call you wrong and everything like that because they want to save those couple CPU times. That's why malloc doesn't clean up memory. It gives you a chunk of memory, whatever the hell was in that memory. It doesn't clean it up at all. Java will clean it up. JavaScript will clean it up. A lot of other languages will clean up. C++ won't. Just letting you know. Why doesn't it? Because C++ is the fastest language on the planet, right? It is smoking fast, but that's the cost. You have to worry about everything yourself. Of all the tree nodes, yep. And the child pointers just point to eventually when we struck, all we did was I made an emporium essentially. So let's do this. I made, here we go, -1, 2, 3. I made an array of, no, just one after the other. Let's put a square bracket around the whole thing. And then I keep on finding one of these things, one of these nodes, and saying, okay, I'm going to hook up my children. My children, these automatically have little pointers to them, but I'm hooking them all up. And now all I need to know is where that first node is, and then I can find everything else. The array is just to make the nodes initially and hook everything up. I don't need to store, I don't need to keep the array around. I keep the array around to clean up the variable, the structs afterwards. When I'm done with it, I call malloc and make an array of tree nodes, and then I call free to clean up the array of tree nodes when I'm done. So there's an array of tree nodes and the child pointers on each one of them, and they each point to another node in the array. Yeah, that's exactly right. Just want to double clarify things. So all they're doing is it's nodes pointing to other nodes. A linked list, which we have slides on, is a node pointing to one other node, which points to another node. And you just get this chain reaction. This one points to this, points to this. It's a conga line. It's a data structure conga line. That's all it is. And once you get a handle of it, play around with this a little bit, it makes perfect sense. But first, it can be a little intimidating. I fully admit that. So that's tree data structure number 1. So the tree itself, all I need is the root of the tree, the top of the tree. That ever can find everything else from there. So if I want to, if I want to chop down a tree and bring it into New York for their Christmas celebration at Rockefeller Center, right? You can grab the base of the tree, the root of the tree, everything else is attached. So you just drag the root with, you shouldn't because you'll destroy it on the highway. But the root of the tree, everything's connected to that root. So you just need to move the root around. The tree itself just has the root and everything's connected to the root, and I'm done. That's all I need for a tree. I need the root, the starting point, and everything else goes from there. If you have a choose your own adventure, there's a page 1, there's a starting page, and everything else is connected from there. There's no I don't know if you know what a choose your own adventure book is. That may date me a bit, right? But most things have a starting point. Even if they branch off, there's always a starting point. Okay, so that's the tree that just points to the starting point, and then that's connected to everything else. And this thing is just a convenience. This thing is, okay, I have my tree. Okay. And later on, when I need to clean up my array, where's my array? Oh, it's also in there. This is just a wholesale bundling up of stuff I might need. So when I don't have to be I had my previous implementation of this was a pain in the ass to try and get your head around. Versus, this still might be a pain in the ass to get your head around, but versus trying to figure everything out is, okay, I got a root. I got the array that I got to clean up later. So when I make the array, it's there. And when I need to free it up, it's there. How big is the array? It's there. That's it. The uncommenting line 54. When you uncommenting line, so uncommented line, then you get nothing in the console whatsoever. That's a little weird. So here's line 54. Instead of calling gen tree, I commented out line 51. because I'm not going to use the gentry. I'm going to use the read tree file thing. And now I'm calling that function. So if once you call that function, okay. So once you call that function, it should make a tree, and then everything else should still happen. So I don't know why you wouldn't. I would have to look at your code, because if you, and you can probably send on my way in Discord or something like that. I'm gonna have to eat supper first, but if you make a tree, if this thing is making a tree for you, you can still do the same tests as before. So it shouldn't change anything at all to your code. I mean, it should show you're making a different tree, but nothing should have changed. For a person, you need to write the reflections. No, each person should, thank you, Sean. Each person should write a reflection. Presumably you learn different things. It could be my partner sucks, or it could be I learned something new, or I let my partner do all the work. I don't know. But you commented out gentry, but you didn't comment out, and you made, what's the other one called? Read tree file, right? If you commented out gentry and you made tree file, then yeah, that should do it for you. Oh, you got to move this thing down. There we go. That wouldn't even compile otherwise, or it shouldn't compile. I can't tell you why you wouldn't get anything at all, because you should. I would, again, put a breakpoint. I'd go into read tree file, find where read tree file is, and I go, okay, well, you want to tell me you're not getting anything? If I get to read tree file and I get to this line and it stops, I know I'm in read tree file. It's breakpoint, printf statements, and deduce what your code does. There's an art form to figuring out exactly the kind of message you need to know exactly what's going wrong, right? And oftentimes it's just looking at what the variables are saying, or a printf statement to see what the heck's, what would be output at this line. Like, what is the value for num nodes, here versus num nodes down here? Right? Okay, so yeah, we're going a little long here. So I'm going to stop it at this, and I'll be posting this video as soon as I can. And then so other people can look at it if need be, and you can review if there's anything that didn't make sense, but made sense at the time, it doesn't make sense anymore. You can review it. And if you need to, just contact me on Discord and ask for help, or contact Pat. He's also there and he loves to help, and just see, and we can try and help you out. I mean, we're not going to give answers, but we're going to try and unstick you so you don't spend 14 hours on a homework. It's not meant, it's meant to be like 2, maybe 3. That's what we're aiming for. So if you're spending way more than that, just double check, make sure that you're not spinning your wheels somehow. Okay. No problem. Have a good night, guys, and I will hopefully talk to you soonish. Thanks.